Hey guys, the next set of notes is on time zones. I just want to get you guys familiar with the way the time zones work and also time based on the rotation of the Earth. So local time is the time based on the rotation of the Earth, and the way it works, places on the same longitude line will have the same local time typically. Not always 100% true, because if you do go north and south on the globe, usually are in the same time zone, except if the time zone curves a little bit. The reason why they curve it is if there's a border of a state or a country and they don't want to split it into two separate time zones, they follow the border line of the state or country. So I'll show you diagrams of that in a moment. But generally, if you go north and south on the globe, the time does not change. If you go east, you go ahead in hours, so towards Europe, they're ahead of us right now. So they're later in the day. Whereas if you go west towards California, you actually go behind in hours. Okay, local solar time. So in general, there's 360 degrees in one rotation, divided by 24 hours in a day, and we get 15 degrees per time zone. So there's 24 time zones in the world, 15 degrees apart. And Greenwich Mean Time, that's the time on 0 degrees longitude of the prime meridian. That's the first time zone. So they base our time zones on that Greenwich Mean Time. And actually the military works on that time throughout the whole globe. They sometimes call it Zulu time. Also weather forecasts are done in that also. Also, the last time zone is actually 180 degrees longitude, known as the International Dateline. They had to pick somewhere in the globe where the date would change first. So once the Earth rotates past that point, the places on the other side of that line will end up being in the next day. And the other side, they actually are the longest time to get to the end of the day. All right, so here's how rotation works with the time zones. Okay, so if we have a North Pole view of the Earth, so this is looking down on the North Pole in the center, and sunlight comes in, lights up half the Earth. So that's daytime here. Nighttime is on the other side, opposite the sun, and we rotate counterclockwise. Okay, and as we rotate, noontime would be the middle of the sunlight. As we rotate from light to dark, that's 6 p.m. or sunset. All right, and this is taking it so it's equal daylight. So this is actually on the equinox when we do this. But either way, light to dark, that's sunset. And then you get to the middle of the night here, that's midnight, 12 a.m. And then you rotate from dark to light now, then you're at sunrise, so 6 a.m. here. And you can do in between times, so right here would be about 9 a.m. Okay, and then 11 a.m. would be pretty close to noon, etc. So you can go all the way around this and figure out the approximate time. Here's another view. This is a side view. This is looking at the globe from a side standpoint. So North Pole is here, South Pole is on the bottom. Now we're rotating counterclockwise, which would be this way around the globe. So I like to think of it as west to east. I think that's a little more, makes a little more sense in this diagram. So this way across the equator. So this time, 12 midnight is the same place. Noontime is over here, same place. Thing that changes is 6 a.m., 6 p.m. 6 a.m. is this whole line, because this is a line of longitude going from north to south pole. And we're rotating from dark to light all along this line. So it doesn't matter where I am on this line, this is 6 a.m. 6 p.m. is on the other side of the globe, out of view. So if you kind of look at the previous diagram, which we looked at before, 6 p.m. was here, but we rotated the globe, so now we're only looking at this bottom side here. And as a result, again, 6 a.m. is in your view, 6 p.m. is on the other side of the globe, out of your view. So that's another way to look at the way the time zones work. Okay, and here's just a little animation of it, gotten from a teacher from upstate New York. Basically the same idea, so you're rotating, this is the North Pole view one. So you can see this little blinking dot, that's New York State. Okay, and you notice, rotate into the dark, that's sunset. Here's midnight, 6 a.m. is sunrise, and then noontime as it comes here. Okay, so this is the sun rays from the opposite direction, so they just looked at the globe from the other side. So the sun's hitting this side instead of that side. But the same idea. All right, the world time zones. So again, Greenwich Mean Time would be right here. Okay, so here's England. Here's the international dateline. So again, 24 time zones as you go around the globe. And that's the way it works. The United States, we have 4 major time zones in our lower 48 states. So right here, you got Eastern time zone, then you have Central time zone, which are the middle states, and then you have Mountain time zone, and then finally Pacific time zone. Okay, so if you ever traveled around the United States, you're definitely familiar with it. Also, if you go to Alaska and Hawaii, they are separate time zones as well. Okay, and you may ask, why do these Arizona, Indiana, and Hawaii got the stripe pattern on it? The reason why, they don't follow daylight savings time. So as a result, during the summertime, Arizona becomes part of the Pacific time zone. And then during the winter time, it becomes part of the Mountain time zone. So not changing your clock at all. The same thing with Indiana. Indiana is part of the Central time zone during the summertime. During the winter time, it becomes part of the Eastern time zone. So that's one difference with those states. But in general, it's 1 hour per time zone. So when we do this, so just to give you an example, so if it is, let's pick a time here, it's 4 p.m. in New York. Okay, it's going to go back an hour here, so Central time zone is going to be 3 p.m. And then Mountain time zone, which is here, is going to be 2 p.m. Sorry, not the best color for there. And then lastly, we go to the Pacific time zone, they're at 1 p.m. So all you have to do is count backwards from New York, if they give you this New York time, and then go back 1 hour for each. And remember, it's 1 hour per time zone. If you go towards the west, you're going back in time. If you go towards the east, you go ahead in time. So if they give you one of the middle ones, you would just count 1 hour the other way. All right, and that's pretty much it. That's the general patterns of the time zones. All right, so hopefully you guys got that. And again, you can see this with TV programs. All right, sometimes they say 10-9 Central. That's what they mean. So 10 in the Eastern time zone, 9 Central. Okay.